On the morning of March 14, 1991, a McDonnell Douglas DC-932 operating as Data Air Flight 114 landed at Philadelphia International Airport carrying 73 passengers and a crew of 5. The aircraft taxied to Gate B-17, where ground crew approached to begin standard turnaround procedures. What they documented in their service logs that day would become the central puzzle in one of the most thoroughly investigated yet quietly suppressed incidents in American commercial aviation history. The aircraft's fuel tanks contained 4,200 pounds more fuel than the flight plan indicated should remain after a scheduled 1-hour 43-minute flight from Cleveland Hopkins International Airport. The auxiliary power unit had logged 47 fewer operating minutes than ground power connection timestamps at Cleveland indicated it should have. And every clock aboard the aircraft, including the cockpit chronometers, the flight management computer, and even the battery-powered backup instruments, showed a time exactly 18 minutes behind the synchronized airport clocks in Philadelphia. 11 hours earlier, at 6:42 a.m. Eastern Standard Time, Data Air Flight 114 had pushed back from Gate C-24 at Cleveland Hopkins International Airport under entirely routine circumstances. Data Air, a regional carrier operating scheduled passenger service throughout the Great Lakes and Mid-Atlantic regions, maintained a fleet of 12 DC-9 aircraft on routes that rarely exceeded 500 nautical miles. Flight 114 followed a path the airline had operated 6 days per week for the previous 14 months, departing Cleveland at 7:00 a.m. and arriving in Philadelphia at 8:43 a.m. The scheduled block time of 1 hour and 43 minutes included taxi, takeoff, cruise, and approach phases across a direct routing that passed over Youngstown, Ohio, skirted the southern edge of the Pittsburgh control area, and crossed into Philadelphia approach airspace near the Pennsylvania-Maryland border. Captain Raymond Decker, age 51, had logged 14,200 total flight hours, with 3,800 hours in the DC-9. First Officer Janet Hollis, age 34, had accumulated 6,100 total hours and 1,900 in type. 3 flight attendants completed the crew manifest. The passenger load that morning reached 73 in a cabin configured for 115, a typical midweek load factor for the route. Weather conditions across the flight path showed scattered clouds at 8,000 feet, visibility greater than 10 statute miles, and light winds from the west-southwest at 12 knots. No precipitation, turbulence, or significant weather activity appeared on forecast models. Air traffic control had assigned Flight 114 an initial altitude of 15,000 feet with an expected final cruise altitude of 27,000 feet, standard parameters for the 280 nautical mile journey. The cockpit voice recorder captured standard pre-flight procedures beginning at 6:38 a.m. Captain Decker and First Officer Hollis completed checklist items with the practiced efficiency of a crew that had flown together regularly over the previous 8 months. At 6:51 a.m., Cleveland Ground Control cleared Flight 114 to taxi to runway 24 left. At 7:04 a.m., Cleveland Tower cleared the aircraft for takeoff. The flight data recorder showed rotation at 138 knots, liftoff at 7:04 and 52 seconds, and a climb rate of 2,200 feet per minute as the landing gear retracted and the aircraft established its departure heading of 095 degrees. First Officer Hollis, the pilot flying for this leg, maintained precise control inputs. Captain Decker handled radio communications and monitored aircraft systems. Every parameter fell within normal operating limits. At 7:07 a.m., Cleveland Departure Control contacted Flight 114 and cleared the aircraft to climb to 15,000 feet. Captain Decker read back the clearance. The transponder return showed the aircraft climbing through 4,700 feet on the assigned heading. At 7:11 a.m., Cleveland Departure instructed Flight 114 to contact Cleveland Center on frequency 128.32. Captain Decker acknowledged and switched frequencies. At 7:11 and 34 seconds, he keyed the microphone and transmitted his check-in to Cleveland Center. The response came immediately. Cleveland Center acknowledged Data Air Flight 114, confirmed radar contact, and cleared the flight to climb to flight level 270. Captain Decker read back the clearance at 7:11 and 49 seconds. The flight data recorder showed the aircraft leveling at 15,000 feet momentarily before resuming its climb toward the newly assigned altitude of 27,000 feet. For the next 6 minutes, the flight proceeded exactly as filed. The aircraft maintained its programmed climb profile. The engines operated within normal temperature and pressure ranges. Fuel flow matched predicted consumption rates. At 7:17 a.m., Cleveland Center cleared Flight 114 direct to the Phillipsburg VOR, a navigational waypoint that would position the aircraft for entry into the Pittsburgh sector airspace. Captain Decker acknowledged. First Officer Hollis entered the routing change into the flight management system. The autopilot adjusted the heading to 102 degrees. At 7:18 a.m., the aircraft leveled at flight level 270. At 7:18 and 41 seconds, Captain Decker reported level at assigned altitude. Cleveland Center acknowledged the report. What happened in the following seconds depends entirely on which data source you trust. According to Cleveland Center's radar records, Flight 114's transponder return remained steady and clear as the aircraft proceeded on course toward Phillipsburg. The data block accompanying the radar return showed altitude, heading, and ground speed updating normally every sweep of the radar antenna. According to the cockpit voice recorder, which operated on a continuous 30-minute loop that preserved the final half hour of the flight, the crew continued routine cockpit operations with no indication of distress, confusion, or abnormal conditions at any point between the level off at 7:18 a.m. and the initial contact with Philadelphia approach control. According to the flight data recorder, which captured hundreds of parameters at intervals ranging from 1 to 8 seconds, every aircraft system continued to function within limits from takeoff to landing with no gaps, interruptions, or anomalous readings in any recorded channel. But according to the air traffic control transcript from Cleveland Center, something did change at 7:19 a.m. At that moment, controllers noted that Flight 114's transponder return disappeared from their radar scopes. The primary radar return, the raw reflection of radio waves off the aircraft's metal surface, remained visible. The data block vanished. Controllers immediately attempted radio contact. No response came. For 43 seconds, Cleveland Center controllers transmitted repeated calls to Data Air Flight 114 on the assigned frequency. The cockpit voice recorder captured none of these transmissions. At 7:19 and 43 seconds, the transponder return reappeared. At 7:19 and 51 seconds, Cleveland Center radioed Flight 114 to verify altitude and transponder operation. Captain Decker responded immediately, confirming level at flight level 270 with transponder set to the assigned code of 3417. The controller asked if the crew had experienced any radio or electrical problems. Captain Decker reported negative, all systems normal, no anomalies noted. Cleveland Center documented the transponder interruption as a brief equipment malfunction, a common enough occurrence in an era when solid-state avionics occasionally showed intermittent failures. Controllers flagged the event in their shift log, but took no further action. Flight 114 continued on course. At 7:24 a.m., Cleveland Center cleared the aircraft to contact Pittsburgh Center on frequency 135.67. Captain Decker read back the clearance and switched frequencies. At 7:24 and 19 seconds, he checked in with Pittsburgh Center. Pittsburgh Center acknowledged radar contact and confirmed the aircraft's routing and altitude. Nothing in the controller's tone or the captain's response suggested anything unusual. Over the next 18 minutes, Flight 114 flew through Pittsburgh Center's airspace on a southeasterly heading toward Philadelphia. Radio communications occurred at normal intervals. The aircraft maintained assigned altitude and speed. At 7:42 a.m., Pittsburgh Center cleared Flight 114 to contact Philadelphia Approach Control on frequency 124.35. Captain Decker acknowledged. At 7:42 and 28 seconds, he established contact with Philadelphia Approach. The controller acknowledged Data Air Flight 114, confirmed radar contact, and issued descent instructions to 11,000 feet. Captain Decker read back the clearance. First Officer Hollis disconnected the autopilot altitude hold and began a controlled descent. At 7:49 a.m., Philadelphia Approach cleared the flight further descent to 5,000 feet and issued vectors for a visual approach to runway 27 right. At 7:56 a.m., the controller cleared Flight 114 to contact Philadelphia Tower. At 7:57 a.m., the tower controller cleared the aircraft to land. The landing occurred at 8:01 a.m. The flight data recorder showed touchdown at 132 knots with a descent rate of 420 feet per minute, well within the aircraft's operational envelope. The main gear made contact first, followed 2 seconds later by the nose gear. Reverse thrust engaged normally. The aircraft decelerated smoothly and exited the runway at taxiway Echo. Tower instructed Flight 114 to contact ground control. At 8:03 a.m., ground control cleared the aircraft to taxi to gate B-17. At 8:06 a.m., the aircraft came to a complete stop at the gate, and Captain Decker shut down the engines. Passengers disembarked without incident. Most noticed nothing unusual about the flight. Several would later tell investigators they had experienced an entirely normal, uneventful trip. The cabin crew performed standard post-flight duties. Captain Decker and First Officer Hollis began shutdown procedures and paperwork. At 8:14 a.m., a ground services mechanic named Thomas Kellerman approached the aircraft to perform a routine inspection and fuel service. Kellerman had worked for Data Air's ground handling contractor for 6 years and had serviced DC-9 aircraft hundreds of times. He carried a clipboard with the flight's fuel load information transmitted from Cleveland before departure. According to the documents, Flight 114 had departed Cleveland with 12,800 pounds of fuel. The flight plan predicted a burn of 6,400 pounds for the trip, leaving approximately 6,400 pounds remaining on arrival in Philadelphia. Kellerman climbed the ladder to check the fuel quantity gauges in the cockpit. Captain Decker remained in the left seat, completing logbook entries. Kellerman asked the captain to confirm the fuel state. Decker glanced at the fuel panel and read the totalizer, 10,600 pounds. Kellerman looked at his clipboard, then back at the gauge. He asked the captain to repeat the reading. Decker confirmed 10,600 pounds. Kellerman descended the ladder and walked to the fuel service panel on the underside of the fuselage. He performed a manual dipstick measurement of both main wing tanks. The physical measurement confirmed the cockpit indication. The aircraft held 10,600 pounds of fuel. Kellerman returned to the cockpit and showed Captain Decker the discrepancy. If the aircraft had departed Cleveland with 12,800 pounds and had burned the predicted 6,400 pounds, it should have arrived with approximately 6,400 pounds. Instead, it held 10,600 pounds, a difference of 4,200 pounds. Either the departure fuel load had been recorded incorrectly, or the aircraft had burned 4,200 pounds less fuel than the flight plan predicted. A DC-932 at normal cruise settings burns approximately 3,800 pounds of fuel per hour. The excess fuel represented roughly 66 minutes of cruise flight that had not occurred. Captain Decker pulled the maintenance logbook and reviewed the Cleveland departure paperwork. The fueling receipt, signed by the Cleveland ramp supervisor at 6:30 a.m., confirmed delivery of 8,600 pounds of fuel to an aircraft that had arrived from Detroit the previous evening, with 4,200 pounds remaining, bringing the total load to exactly 12,800 pounds. The fueling contractor's truck meter reading and the ramp supervisor's verification both documented the transaction. Decker radioed Data Air operations in Philadelphia and reported the fuel discrepancy. The operations supervisor logged the report and contacted the airline's maintenance control center. At 8:47 a.m., a Data Air maintenance inspector named Carl Hoffman arrived at Gate B-17 to investigate. Hoffman interviewed Captain Decker and First Officer Hollis separately. Both crew members stated the flight had proceeded normally from departure to arrival with no anomalies, no unusual events, and no deviations from the flight plan. Hoffman asked whether they had experienced any electrical problems, autopilot disconnects, navigation errors, or periods when they were out of radio contact with air traffic control. Both crew members said no. Hoffman asked whether the flight had encountered headwinds significantly lighter than forecast, which might account for reduced fuel consumption. Captain Decker said the winds had been as predicted, light and variable, with no significant tailwind component. Hoffman asked if the aircraft had flown at a lower altitude than assigned, which would reduce fuel burn. First Officer Hollis confirmed they had flown the entire route at the assigned altitude of flight level 270, except during climb and descent. Hoffman retrieved the aircraft's flight data recorder and cockpit voice recorder and sent them to Data Air's engineering facility in Chicago for analysis. He also pulled the paperwork from Cleveland and examined every fuel document from the previous 3 flights the aircraft had operated. Every fuel load, every burn calculation, and every remaining fuel quantity matched expected values within normal tolerances. Only Flight 114's arrival fuel showed an anomaly. Hoffman then performed a complete inspection of the fuel quantity indicating system. He checked the fuel probes, the wiring, the gauges, and the totalizer computer. Every component tested within specifications. He performed a fuel system functional check. The system responded correctly to all inputs. There was no indication of a malfunction that would cause the gauges to read 4,200 pounds high. That afternoon, Hoffman filed a preliminary maintenance report documenting the discrepancy as unexplained, but noting that all aircraft systems tested normal and the airplane was released for continued service. The report triggered a review by Data Air's Director of Safety, a former Air Force investigator named Ellen Marsh. Marsh had spent 12 years analyzing aircraft mishaps and understood that unexplained fuel discrepancies could indicate serious problems ranging from fuel leaks to sabotage to instrument failures that might affect other systems. She ordered a more detailed investigation and requested that the Federal Aviation Administration be notified. On March 15th, an FAA airworthiness inspector named Donald Pierce traveled to Philadelphia to examine the aircraft and interview the crew. Pierce pulled the maintenance logs and confirmed Hoffman's findings. He then requested the flight data recorder analysis from Chicago. The results arrived by fax on March 18th. The engineering team had downloaded every parameter recorded during Flight 114's journey from Cleveland to Philadelphia. The data showed a completely normal flight profile. Climb rate, airspeed, altitude, engine performance, fuel flow, and every other monitored variable fell within expected ranges. The fuel flow totalizer, which integrated fuel flow over time to calculate total fuel consumed, showed a total burn of 6,380 pounds from engine start in Cleveland to engine shutdown in Philadelphia. That value matched the flight plan prediction within 20 pounds. Pierce read the report twice. If the fuel flow data was accurate and the departure fuel load of 12,800 pounds was accurate, the aircraft should have arrived with 6,420 pounds remaining. But physical measurement confirmed 10,600 pounds on arrival. The numbers did not reconcile. Either the flight data recorder had failed to capture the actual fuel flow, or the fuel had been added to the aircraft by some means during the flight, or the departure fuel load had been misrecorded by nearly 50%. Pierce reviewed the Cleveland fueling documentation again. 3 independent people had verified the fuel load: the fueling truck operator, the ramp supervisor, and the flight crew during pre-flight inspection. The probability of all 3 making the same error approached 0. Pierce contacted Cleveland Hopkins Airport and requested access to the fueling contractor's truck that had serviced Flight 114 on the morning of March 14th. On March 20th, he flew to Cleveland and met with the contractor's operations manager. They pulled the maintenance and calibration records for the truck. The vehicle had been calibrated 4 days before the incident and had serviced 16 aircraft in the interim. Every fuel delivery matched the expected quantities within acceptable tolerances. The meter functioned correctly. There was no indication the truck had under-delivered fuel to Flight 114. Pierce then interviewed the truck operator who had fueled the aircraft. The operator, a 23-year veteran named Michael Reese, remembered the service call clearly. He stated he had delivered exactly 8,600 pounds as requested, had watched the meter throughout the transfer, and had verified the total with the ramp supervisor. Both men had signed the delivery receipt. Pierce returned to Philadelphia and requested a detailed analysis of air traffic control radar data for Flight 114. The FAA's Technical Center in Atlantic City processed the request and provided a minute-by-minute reconstruction of the aircraft's flight path based on radar returns from Cleveland Center, Pittsburgh Center, and Philadelphia Approach Control. The data showed the aircraft departing Cleveland at 7:04 a.m., climbing on the assigned heading, leveling at 27,000 feet at 7:18 a.m., and proceeding on course to Philadelphia with a landing time of 8:01 a.m. Total elapsed time from takeoff to landing, 57 minutes. Total elapsed time from engine start to engine shutdown, as documented in the cockpit logbook, 1 hour and 24 minutes, consistent with the scheduled block time of 1 hour and 43 minutes accounting for the early departure and slightly faster taxi times. But when Pierce compared the radar data timeline to the cockpit voice recorder transcript, he found something that made him sit back in his chair and read both documents again. The cockpit voice recorder captured the final 30 minutes of the flight on a continuous loop. The recording began at 7:36 a.m., based on timestamps from the ground power disconnect in Cleveland synchronized to the aircraft's cockpit clocks. It ended at 8:06 a.m. when the engines shut down in Philadelphia. Total recording duration, 30 minutes, exactly as expected. But according to the radar data, the aircraft had been airborne from 7:04 a.m. to 8:01 a.m., a flight time of 57 minutes. If the cockpit voice recorder had captured the final 30 minutes of the flight, it should have begun recording at approximately 7:31 a.m., not 7:36 a.m. The 5-minute discrepancy suggested the aircraft's cockpit clocks were running slow. Pierce requested that the cockpit voice recorder be sent to the FAA laboratory for a technical analysis of the recording's actual duration. The lab measured the tape speed and confirmed that 30 minutes of recording time had passed at the correct recording rate. The tape had not been damaged, stretched, or altered. 30 minutes of conversation had been captured, beginning at 7:36 a.m. and ending at 8:06 a.m. according to the timestamps embedded in the crew's time-referenced radio calls. Pierce then requested a copy of every radio transmission between Flight 114 and air traffic control from departure to arrival. The FAA provided transcripts with timestamps based on the synchronized clocks used by all ATC facilities. When Pierce laid the transcripts side by side with the cockpit voice recorder timeline, the discrepancy became undeniable. According to ATC records, Captain Decker had checked in with Cleveland Center at 7:11 and 34 seconds. The cockpit voice recorder did not capture that transmission because the recording had not yet begun. According to ATC records, Flight 114 had been cleared to contact Philadelphia Approach Control at 7:42 a.m. According to the cockpit voice recorder, that clearance had been received at 7:42 a.m. But if the cockpit voice recorder had begun at 7:36 a.m., the transmission at 7:42 a.m. should have appeared 6 minutes into the recording. Instead, it appeared at a point in the recording that correlated to 24 minutes elapsed, 18 minutes later than expected. Pierce constructed a timeline comparing ATC records, cockpit voice recorder data, and flight data recorder information. Every correlation showed the same offset. The cockpit voice recorder appeared to be running 18 minutes behind the ATC timeline. Or, more precisely, the aircraft's cockpit clocks appeared to be running 18 minutes behind the synchronized time used by air traffic control and every airport facility. Pierce asked the maintenance team in Philadelphia to check the aircraft's time reference system. They found that every timekeeping device on the aircraft, including the digital chronometers on the instrument panel, the time display on the flight management computer, and the battery-powered backup clock mounted on the center pedestal, showed a time exactly 18 minutes behind the current time in Philadelphia. The aircraft was equipped with 3 independent time sources. The primary system synchronized to a quartz oscillator that powered the flight management computer. The secondary system used a separate quartz oscillator for the cockpit chronometers. The backup clock ran on a small lithium battery and used a mechanical oscillator. For all 3 systems to show the same 18-minute error simultaneously would require either a coordinated failure of all 3 oscillators, which had never been documented in aviation history, or a physical reset of all 3 clocks to the wrong time, which would have required deliberate action by the crew. Captain Decker and First Officer Hollis both stated they had not touched the time settings at any point during the flight. Pierce contacted the FAA's technical center and requested a failure analysis of the scenario where 3 independent timekeeping systems could drift by the same amount simultaneously. The engineers responded that quartz oscillators, even low-quality ones, do not drift by 18 minutes over a 1-hour flight. A typical crystal oscillator might drift by a fraction of a second per day. Mechanical watches might drift by several seconds per day. To accumulate an 18-minute error in 1 hour would require a drift rate approximately 10,000 times greater than the physical capabilities of the oscillators. The engineers stated flatly that the scenario was impossible under known physics. On April 2, 1991, Pierce filed a formal incident report with the FAA recommending a full investigation under the agency's authority to examine unexplained anomalies in commercial aviation. The report detailed the fuel discrepancy, the time synchronization problem, and the lack of any technical explanation that reconciled the observed data. The report noted that the crew had reported a normal flight, that all aircraft systems had tested within specifications, and that the aircraft had been returned to service without restriction. The report concluded that the incident posed no immediate safety risk, but warranted further investigation to determine whether a systemic problem existed that might affect other aircraft. The FAA assigned a team of 3 investigators to review the case. They requested additional documentation from Data Air, Cleveland Hopkins Airport, Philadelphia International Airport, and the air traffic control facilities that had handled Flight 114. They interviewed the crew again, this time separately, and with more detailed questions about the flight timeline. Captain Decker and First Officer Hollis provided consistent accounts. Both stated they had monitored cockpit clocks throughout the flight and had noted no discrepancies with the times given by air traffic control. Both stated that when they landed in Philadelphia, the cockpit clocks showed what they believed to be the correct local time. Neither had noticed that the aircraft clocks were 18 minutes slow until ground personnel pointed out the discrepancy after landing. The investigators asked how it was possible for the crew not to notice an 18-minute time error when air traffic control was providing time reference instructions throughout the flight. Captain Decker explained that controllers typically do not state the current time in routine communications. They issue clearances, vectors, and altitudes without time references. The crew cross-checks their cockpit clock against air traffic control only during specific events such as position reports, or when a controller provides an explicit time for an expected clearance. During Flight 114, no such cross-check had occurred. The crew had simply assumed their clocks were correct because they had been correct at departure, and no one had reason to suspect a problem. The investigators then asked whether the crew had felt that the flight had taken longer or shorter than expected. Both crew members stated the flight had felt entirely normal in duration. They had not felt rushed. They had not felt that time was passing slowly. The workload and pacing had been typical for the route. First Officer Hollis added that she had glanced at the cockpit clock several times during cruise and had noted that the flight was progressing as expected based on the displayed time. If the clock had been running 18 minutes slow, she should have felt the flight was taking longer than the clock indicated. She did not recall that sensation. On April 18th, the FAA team interviewed the Cleveland Center controller who had handled Flight 114 during the transponder interruption at 7:19 a.m. The controller, a 9-year veteran named Peter Carlson, reviewed the radar tapes and his shift log. He confirmed that the transponder return for Flight 114 had disappeared from his scope at 7:19 a.m. and had reappeared at 7:19 and 43 seconds. He stated that the primary radar return had remained visible throughout. He described the event as unremarkable, a brief transponder dropout consistent with an intermittent electrical fault. He noted that he had queried the crew immediately upon re-establishment of contact and that the captain had reported no anomalies. Carlson stated he had handled dozens of similar transponder dropouts over his career and had not considered this event unusual. The investigators asked Carlson to estimate how far Flight 114 had traveled during the 43 seconds when the transponder was not transmitting. Carlson calculated that at the aircraft's ground speed of approximately 460 knots, the plane would have covered about 6 nautical miles during the dropout. The investigators then asked whether the primary radar return had remained steady during those 6 miles. Carlson reviewed the radar tapes frame by frame. The primary return appeared on every sweep of the radar antenna. The target moved along a consistent track at a consistent speed. There was no indication the aircraft had maneuvered, climbed, descended, or deviated from course. The only anomaly was the absence of the transponder data. The investigators submitted a request to the National Transportation Safety Board to examine whether the incident qualified for a formal accident investigation. The NTSB reviewed the file and determined that since no injury, damage, or safety violation had occurred, the incident did not meet the threshold for a full investigation. The NTSB recommended that the FAA continue its inquiry and provide a final report with recommendations if warranted. The FAA team continued gathering data through May and June of 1991. They pulled maintenance records for the accident aircraft going back 2 years. They reviewed the training files for Captain Decker and First Officer Hollis. They examined weather data, flight plan routing, and air traffic control procedures for any factor that might explain the observed anomalies. They found nothing. In July, the FAA team requested that the aircraft be taken out of service for an intensive systems test. Data Air complied and ferried the DC-9 to a maintenance facility in Fort Worth, Texas, where technicians performed a complete diagnostic workup on every system. They tested the fuel quantity system, the electrical system, the navigation system, and the flight instruments. They downloaded the flight management computer's non-volatile memory and analyzed the stored data for anomalies. They disassembled the cockpit chronometers and examined the quartz oscillators under laboratory conditions. They measured the frequency stability of every crystal in the aircraft. Every component tested within specification. The aircraft was released for service and returned to Data Air's fleet on August 3rd. On September 12, 1991, the FAA issued a final report on the incident. The report documented the fuel discrepancy, the time synchronization problem, and the transponder dropout. It noted that no technical failure had been identified that could explain any of the observed phenomena. The report stated that the fuel discrepancy might have resulted from an undetected error in fuel load documentation at Cleveland, although no such error could be confirmed. The report suggested that the time synchronization problem might have resulted from an inadvertent reset of all cockpit clocks by the crew, although the crew denied performing such a reset. The report acknowledged that the transponder dropout could not be explained by any identified equipment fault. The report concluded that the incident posed no ongoing safety risk and recommended no further action. The file was closed. Data Air's Director of Safety, Ellen Marsh, was not satisfied with the FAA's conclusions. She believed that the combination of 3 unexplained anomalies occurring during the same flight suggested a deeper problem that had not been identified. In October 1991, she contracted with an independent aviation consulting firm to perform a separate analysis of the incident. The firm, Aviation Systems Analysis Group, specialized in failure mode and effects analysis for commercial aircraft. The team spent 6 weeks reviewing the data. In December, they delivered a 78-page report to Data Air. The consulting firm's report began by noting that the 3 anomalies, fuel discrepancy, time error, and transponder dropout, occurred on different systems with no common failure mode. The fuel system was independent of the electrical system that powered the transponder. The timekeeping systems were independent of both. For all 3 systems to show anomalies simultaneously suggested either an external event that affected the aircraft as a whole or a series of independent failures that coincidentally occurred during the same flight. The report calculated the probability of 3 independent system failures occurring simultaneously as approximately 1 in 40 million flight hours, a rate so low that such an event should occur once every 4,000 years of continuous commercial aviation operations. The report then examined the possibility of an external event. The consultants noted that high-intensity electromagnetic fields, such as those generated by lightning strikes or proximity to high-power radar installations, can temporarily disrupt aircraft electronics. However, such events typically cause immediate and obvious effects, including radio interference, compass deviations, and crew-reported anomalies. Flight 114's crew had reported none of these. The weather had been clear with no thunderstorms within 200 miles of the flight path. No military radar installations or other high-power emitters were operating near the aircraft's route at the time of the flight. The consultants then analyzed the time discrepancy in detail. They noted that an 18-minute error in cockpit timekeeping would affect not only the clocks, but also any system that relied on time data. The flight management computer used time calculations to determine fuel predictions, waypoint arrival estimates, and navigation updates. If the computer's time reference had been incorrect by 18 minutes, it should have produced erroneous navigation data. The investigators pulled the navigation logs from the flight data recorder and compared them to the actual aircraft position as determined by radar. The navigation system had functioned perfectly. Every waypoint passage time matched the expected time based on ground speed and distance. The computer's time reference appeared to have been correct, even though the displayed time on the cockpit clocks was 18 minutes slow. This finding created a new puzzle. The flight management computer and the cockpit chronometers received their time reference from the same master oscillator. If the oscillator had drifted by 18 minutes, both systems should have shown the same error. But the navigation log showed correct time-based calculations, while the displayed clock time was incorrect. The consultants concluded that either the clock display system had failed independently of the computer's internal timekeeping, or the internal timekeeping had been correct while the clocks displayed an erroneous value. They tested this hypothesis by examining the flight data recorder's timestamps. The recorder generated timestamps based on its own internal clock, which synchronized to the aircraft's master oscillator at power-up. The flight data recorder showed that the flight from Cleveland to Philadelphia had lasted 57 minutes of actual flight time plus taxi and ground operations, consistent with the radar data and air traffic control records. The recorder's internal clock had tracked real time correctly. Yet the cockpit displays, which drew their time data from the same source, showed a time 18 minutes slow. The consultants concluded that a fault must have existed in the interface between the master clock and the display systems, a fault that affected the displayed time without affecting the computer's internal calculations. They recommended that Data Air issue a service bulletin requiring inspection of this interface on all DC-9 aircraft in the fleet. Data Air complied and issued the service bulletin in January 1992. Maintenance crews inspected the clock interface wiring on all 12 DC-9s in the fleet. No faults were found. The consulting firm revised its hypothesis and suggested that a transient electronic glitch, possibly caused by a brief voltage spike or electromagnetic pulse, might have corrupted the clock display without affecting other systems. Such glitches were known to occur occasionally in aging avionics. The firm recommended enhanced electrical system monitoring on all aircraft, but acknowledged that the specific cause of the Flight 114 anomalies would likely never be determined with certainty. Ellen Marsh filed the consulting report with Data Air's safety records and moved on to other matters. The aircraft that had operated as Flight 114 on March 14, 1991, continued flying revenue service for Data Air until the airline ceased operations in 1997. The airplane was sold to a South American carrier and operated for another 8 years before being retired and scrapped in 2005. No similar incidents were ever reported on that aircraft or any other DC-9 in Data Air's fleet. Captain Decker retired from the airline in 1998. First Officer Hollis continued flying and eventually upgraded to captain, retiring in 2014. Neither pilot ever experienced another incident resembling the events of Flight 114. In the years following the incident, a small number of aviation safety analysts and independent researchers occasionally revisited the case. In 2003, a retired aerospace engineer named Malcolm Hendricks published an article in a flight safety journal examining unexplained fuel discrepancies in commercial aviation. Hendricks had spent 30 years working on fuel system design and had access to incident databases maintained by aircraft manufacturers and regulatory agencies. He identified 12 incidents over a 40-year period in which aircraft had arrived at their destinations with significantly more or less fuel than predicted by flight planning calculations and flight data recorder logs. Most of these incidents had been explained by fueling errors, instrument failures, or documentation mistakes. 3 cases, including Data Air Flight 114, remained unexplained after exhaustive investigation. Hendricks noted that all 3 unexplained cases shared a common characteristic. The fuel discrepancy was accompanied by other anomalies in timekeeping, navigation, or communication systems. In one case from 1978, a Boeing 727 had arrived in Denver with 3,000 pounds more fuel than expected, and the crew had reported that the flight seemed shorter than usual, although all clocks agreed on the elapsed time. In another case from 1986, a DC-10 had landed in Chicago with 5,500 pounds less fuel than predicted, and post-flight analysis showed a 4-minute gap in the cockpit voice recorder that the manufacturer attributed to a tape recording error. Hendricks did not offer an explanation for these cases. He simply noted that they existed, that they defied conventional analysis, and that they suggested a phenomenon that aviation authorities had not adequately characterized. In 2008, a former air traffic controller named Rebecca Torres published a book examining unusual radar tracking events she had witnessed during her 26-year career. One chapter discussed the Flight 114 transponder dropout. Torres had obtained a copy of the radar data through a Freedom of Information Act request and had analyzed it in detail. She noted that the 43-second transponder dropout had occurred at precisely 7:19 a.m., according to Cleveland Center's timestamp. She also noted that when the transponder return reappeared at 7:19:43 a.m., the aircraft's reported altitude was identical to the altitude reported before the dropout, flight level 270. During a 43-second period at 460 knots ground speed, the aircraft would have traveled more than 6 nautical miles. Even a perfectly level flight would show minor altitude variations of 50 to 100 feet due to atmospheric turbulence and autopilot corrections. The fact that the altitude was identical to the foot suggested the transponder had simply stopped transmitting and then resumed without the aircraft actually moving during the dropout. Torres was careful not to speculate about what this meant. She noted only that the data did not match the expected behavior of a transponder experiencing an electrical fault. A failing transponder would typically produce intermittent or corrupted signals, not a clean 43-second interruption followed by perfect resumption. Torres contacted Cleveland Center and requested information on whether any other aircraft in the vicinity of Flight 114 at 7:19 a.m. had experienced radio or radar anomalies. The FAA responded that no other anomalies had been recorded. Flight 114 had been the only aircraft showing unusual behavior. In 2016, a physicist named Dr. Lawrence Tennant published a paper in a peer-reviewed journal examining temporal anomalies in high-speed transportation systems. Tennant's work focused primarily on atomic clock experiments aboard supersonic aircraft and satellites, but one section of the paper discussed reported incidents of timekeeping errors in commercial aviation. Tennant referenced the Flight 114 case and performed a theoretical analysis of whether relativistic time dilation could account for the 18-minute clock error. Under special relativity, time aboard a moving vehicle advances slightly more slowly than time in a stationary reference frame. For an aircraft traveling at 460 knots, the time dilation effect amounts to approximately 0.02 seconds per hour of flight. To accumulate 18 minutes of time dilation, an aircraft would need to travel at a significant fraction of the speed of light for an extended period. Tennant concluded that relativistic effects could not explain the observed discrepancy. Tennant then explored whether localized distortions in spacetime, analogous to those predicted by general relativity near massive objects, could theoretically produce time discrepancies. He calculated that to generate an 18-minute time differential over a 1-hour flight would require the aircraft to pass through a region of spacetime where the gravitational potential differed from Earth's surface by a factor equivalent to being in close proximity to a neutron star. Such conditions do not exist anywhere in Earth's atmosphere or near Earth space. Tennant acknowledged that his analysis was speculative and that no known physical mechanism could account for the Flight 114 time anomaly within the framework of established physics. The case has appeared sporadically in aviation forums and safety conferences over the years, usually presented as an example of an incident that defies explanation despite thorough investigation. In 2019, the Flight Safety Foundation included the incident in a database of unresolved aviation anomalies, noting that the combination of fuel, time, and transponder irregularities had never been satisfactorily explained. The Foundation's summary emphasized that all aircraft systems had tested normally after the flight, and that the crew had experienced no subjective sense of anything unusual. The summary concluded that the incident likely resulted from a confluence of unrelated errors and instrumentation faults that happened to occur during the same flight, despite the statistical improbability of such an occurrence. In 2021, a documentary filmmaker researching unexplained incidents in aviation contacted several of the individuals involved in the Flight 114 investigation. Ellen Marsh, by then retired, agreed to an interview. She stated that in 30 years of aviation safety work, she had never encountered another case with the characteristics of Flight 114. She emphasized that the crew had been highly experienced, the aircraft had been well maintained, and the investigation had been thorough. She said she remained convinced that something had happened during that flight that was not captured in the official record, but she had no theory about what it might have been. The filmmaker also contacted First Officer Janet Hollis, who had retired from aviation and was living in Oregon. Hollis agreed to discuss the flight. She stated that she had replayed the events in her mind countless times over the years and remained unable to reconcile her memory of a normal, routine flight with the documented anomalies. She said the flight had felt like any other flight she had operated on that route. The departure, climb, cruise, and approach had all proceeded according to procedure and expectation. When maintenance personnel informed her about the fuel and clock discrepancies after landing, she had been genuinely baffled. She said she had always felt that there was something about the flight that she should have noticed, some detail that would have made the pieces fit together, but she had never identified what it might be. Captain Raymond Decker had passed away in 2012. The filmmaker obtained a copy of a deposition Decker had given during an internal data air review in 1992. In the deposition, Decker had stated that the flight had been entirely unremarkable from his perspective. He noted that he had logged more than 14,000 flight hours over a 30-year career and had experienced various equipment failures, weather events, and emergencies. Flight 114 had not felt like any of those. It had felt like a completely normal flight. He said the fact that the aircraft's clocks were 18 minutes slow when he shut down the engines had been the first indication that anything unusual had occurred. He stated he had checked the cockpit clock against his wristwatch before departure in Cleveland, and both had shown the same time. He had checked his wristwatch again after landing in Philadelphia, and it had matched the airport clocks. Only the aircraft's clocks had been incorrect. That detail, the fact that Decker's wristwatch had remained synchronized with ground clocks, while the aircraft's clocks had not, became a focal point for several researchers who examined the case. If some phenomenon had affected timekeeping aboard the aircraft, it had affected only the aircraft's electronic systems, not mechanical watches or biological perceptions. This selectivity suggested a technological failure rather than a physical anomaly. Yet no technological failure had been found. The aircraft's oscillators, wiring, and display systems all functioned correctly when tested. The anomaly had occurred, been documented, and then vanished, leaving no trace of its cause. In 2023, aviation historian Dr. Emily Cartwright published a comprehensive book examining a century of unexplained incidents in commercial aviation. One chapter focused on Data Air Flight 1 and 14. Cartwright had obtained access to previously unreleased documents through a Freedom of Information Act request, including internal FAA memoranda and communications between investigators during the inquiry. One memo, dated May 7, 1991, caught her attention. The memo, written by FAA investigator Donald Pierce to his supervisor, discussed the decision to close the investigation. Pierce wrote that he remained uncomfortable with the conclusion that the incident resulted from unrelated errors. He noted that the transponder dropout, the fuel discrepancy, and the time error formed a pattern that suggested a single underlying cause. He wrote that if the aircraft had somehow traveled the route from Cleveland to Philadelphia in less time than the clocks indicated, it would account for all three anomalies. Less flight time would mean less fuel burned, explaining the excess fuel. Less flight time would mean the aircraft's clocks, which had been correct at departure, would appear slow relative to ground clocks at arrival, and a transponder dropout at the moment when the time differential began would explain the gap in radar tracking. Pierce noted that no physical mechanism was known that could cause an aircraft to traverse distance in less time than its onboard instruments recorded. He acknowledged that his hypothesis was speculative and unsupported by evidence. He recommended closing the case, but preserving the file for future review if similar incidents occurred. Cartwright's book reproduced the memo in full and noted that no similar incidents had been officially documented in the 32 years since Flight 114. She concluded her chapter by observing that some incidents in aviation history resist explanation not because the data is insufficient, but because the data, when taken as a whole, describes something that does not fit within existing frameworks of understanding. She wrote that Flight 114 might represent such a case, an event that was thoroughly documented and investigated, yet remained fundamentally unexplained because the explanation required accepting premises that could not be reconciled with established principles of physics and engineering. The aircraft, the crew, the passengers, and nearly everyone directly involved with Data Air Flight 114 have now passed into history. The file cabinets containing the investigation records remain in storage at FAA facilities and Data Air's successor companies. The radar tapes, cockpit voice recorder, and flight data recorder have been preserved as part of the historical archive. The fuel receipts, maintenance logs, and crew statements exist on microfilm and digital backup. The data is complete, the documentation is thorough, and yet the central question remains unanswered. An aircraft departed Cleveland with a specific quantity of fuel, flew a specific route, and arrived in Philadelphia with more fuel than the laws of physics should have permitted. The aircraft's clocks advanced 18 minutes less than the synchronized clocks at every airport and control facility it contacted. The aircraft's transponders ceased transmitting for 43 seconds, during which the aircraft appeared to cover 6 nautical miles while reporting an identical altitude at the start and end of the interval. The crew experienced nothing unusual. The passengers noticed nothing wrong. Every instrument test after the flight showed normal function, and no one has ever provided an explanation that accounts for all the observed facts. On any given day, tens of thousands of flights cross the skies above North America, each one generating streams of data captured by transponders, flight recorders, and radar systems. Most of these flights proceed exactly as planned. their data conforming to predictions, and their outcomes matching expectations. But occasionally, perhaps once in a generation, a flight produces data that does not match, outcomes that do not conform, and questions that investigations cannot answer. Those flights leave behind records that sit in archives, reviewed periodically by researchers looking for patterns or insights that earlier investigators might have missed. Data Air Flight 114 remains one of those flights. The official conclusion that unrelated errors coincidentally occurred during the same journey satisfies the requirement to close a case file. It does not satisfy the requirement to understand what actually happened in the sky over Pennsylvania on the morning of March 14, 1991. Somewhere in the data, in the fuel logs, in the radar tracks, in the cockpit voice recordings, in the maintenance reports, there may be a detail that would resolve the mystery. Or perhaps the resolution requires not a closer examination of the data, but a willingness to consider that the assumptions underlying the investigation, assumptions about how time, distance, and physical systems must behave, may have been insufficient to describe what actually occurred. If you follow aviation mysteries and unexplained incidents, subscribe for future investigations.